Welcome to this video on drawing ray diagrams for plane mirrors. But before we start this video, a quick recap. In the previous two videos we saw experiment to demonstrate that incident angle is equal to angle of reflection, and also we saw that image distance was equal to the object distance. So now we have two questions. How are these two related in any ways? Are they related in any ways? And the second question is, how do ray come to my eyes? So first let's answer the second question first, and without telling the why, let's find out the mechanism of how a ray would come to your eyes. So let's assume this is a mirror and you have an object here. We know that image is formed somewhere behind the mirror. So this is the only position where we can remove our parallax and so on. So this image is somewhere over here. Let's mark this by I, and it depends on where you see from. So let's assume you are observing from here. Now a ray of light must be coming from the mirror here, like this. And I'm claiming that if you extend this, your brain is projecting this, and it goes and meets this point. And we know that, hey, this is equal to this. So now let's assume that the object distance is equal to the image distance. That's let's assume that assume AO equal to AI. Now if this ray would have come from here, then the ray would have got reflected from here. So now let's prove that this implies the angle of incident is equal to the angle of reflection. So now in this diagram, let's label all the elements. So this is let's label this point as B, A, and everything is marked, and let this be your normal 1 and this be the perpendicular. So both of these are parallel. The normal 1 and the normal 2, these are both parallel lines because they both are 90 degrees to the mirror. All right. Okay, so now if you observe these two triangles, the triangle ABI and triangle OAB, we can see that BA is a common side, and also you can see angle A is also common, and of course our assumption is that AI equal to AO. So both these triangles are congruent. So we can say that both these triangles are congruent, which implies, and this implies that this angle and this angle are same, right? I can say that angle O equal to angle I. But we know that since these lines are parallel, these are alternate interior angles. So I can say that this I is equal to this I, and we know angle O equal to I, so they are alternate interior. So because of that, your angle I is this is also I, and we know that these two normals are parallel, and hence this angle and this angle are equal. So since N1 and N2 are parallel, angle AIB and angle R are equal. So this implies that angle R equal to angle I. So you may want to pause this video here and try to derive or try to infer this by yourself. So what this says is, if AO equal to AI, angle I is equal to angle R. So we have proved that if one of them is true, then the other is indeed true. So now let's try to do the opposite, and let's say that, you know, let's assume that or let's start from the position that, hey, you know, the angle I and angle R are equal, right? So this is, let's assume this is a ray that comes to you from the object and that reaches your eye. And so what we want to prove is, if these two angles are equal, and this is also I, then we need to prove that OA is equal to AI. So we need to prove that, to prove OA equal to AI, right? The object distance is equal to image distance, and given that what is given, that angle I equal to angle R, right? Because this is R, that's equal to I. So this is quite easy. Again, we use the fact that these two are perpendicular lines, and these are parallel, and these are perpendicular to the mirror, and hence this line, this angle will be equal to this angle I, and similarly, you know, this angle will be equal to this angle I, and I can say that, hey, you know, this is again, these two triangles are congruent. Triangle BAI is congruent to BAO because AB is common, angle A is 90 degrees, and angle O equal to angle I. So these two triangles are congruent. This implies that AI equal to AO. So again, we prove that if angle I is equal to angle R, then this should be true. So so these two mean one and the same thing. So now here is a question. If let's assume that your object is here and your eye is here, and in another case your eye is here, so how would we draw the ray diagrams? So to draw the ray diagrams, all we need to do is we need to draw the perpendicular, mark the point which is equidistance, and we know that the image is here. So the ray, the brain must have projected the ray like this, and this ray comes straight to your eyes. Let me mark this in green. So this ray comes straight to your eyes, and since it has come from here, you know, this ray would have come like this, and we know that since if we take this and this as equal distance, we know that these angles, the angle I and angle R, pardon me for the drawing, they don't look same, but these both must be equal, right? So we know that if this one implies image distance equal to object distance implies that these two angles will be same, provided we take a ray, we draw a line from the incident towards I. So that's how the ray goes out. And for the red, let's assume this mirror is not this long, and let's say it's a short mirror. So here we see that there should have been a ray which should have come to the eye from there, but no such ray can come because there is no mirror here. By the way, I should have indicated this as a mirror. So since there is no mirror, there is no such ray. But if this mirror would have been there, then there would have been a possibility that a ray would have come like this, and that would imply that the ray would have gone from here. So we could have said that if the mirror was extended here, that red eye, the eye at the red position, could also see the image. So that's how you can find out whether you will see the image or not, and that's how you draw ray diagrams. Step one, find I, position of I. Step 2, draw line from I to eyes. And step 3 is once you have the reflected ray, draw incoming ray, which is basically this ray. Once you know that where it meets, then you draw the incoming ray, right? And finally, draw normal, which is this, right? And indicate angle I equal to angle R, right? Which is these angles are equal. So that's how you do it. In the next video, you will see an experiment wherein we draw this and see if if we see that if all these laws are valid. So I hope you'll enjoy that. See you in the next video. Bye.